Hello and welcome to another Deva tutorial. Today we will be explaining how to use the Deva I++ program. First, we need to open the program. Before defining any tools, we need to define the probe head and mount. You can either choose a probe head from the drop-down box or define a custom one. Each of the parameters is explained in their tooltip and the manual. For the mount, you will need to define two unit vectors, the probe direction and the head direction. The probe vector defines the orientation of a probe at angles A0 and B0. The head vector defines the vector facing out from the front of the probe head. Once you have defined a probe head, you can define the calibration spheres you will be using. To create a new sphere, right-click the list and click Add. It will create a sphere with default values. The center of the sphere will be undefined until it is calibrated. To do that, we will need to define a tool. If you have an indexable probe head, the tools will be shown as a tree, with the sub-items being each orientation of the tool. If the probe head isn't indexable, the tools will be shown in a list. The first parameter of a tool is its name. If you are using the rack and tool system, this name should match a tool in the Deva configuration. The rack and tool system can be toggled off and on. When enabled, the tools will be changed using the Deva CMM control rack and tool system. If you have a star, probe I++ is designed to treat them as separate tools. So that the server knows not to change between them, you can add a hash and a secondary character to the name of a tool to differentiate it from another probe on the star. When changing tools, the server will disregard the hash and secondary character. Next, choose the type of tool. Enter the nominal parameter of the probe, its direction, and tool offset. The first parameter of an orientation is the handle. This is the unique label that the client will use to identify it. The handle is derived from the handle format, which is defined in the settings page. If we enter the format delimiter %U, we will be able to enter a custom handle for each orientation. The format delimiters %A and %B are used to represent the A and B angles respectively, and finally, the format delimiter %T is used to represent the tool name. The other parameters of the orientations are the angles. The angles you can choose are derived from the angles the probe head can achieve. Each orientation has a set of parameters like speed and acceleration for different modes like scanning. These can be defined per orientation, tool, or for every tool. To set the parameters for all tools at once, click a tool to set its parameters. When you click Confirm, a dialog box will let you decide whether to set these parameters for all tools or just this tool. You can select different tools by clicking Select on one. If Rack and Tools is enabled, it will change the tool automatically. The currently selected tool is denoted with a white diamond. This will reflect which tool the client has selected. Once you have defined all your tools, select the one you want to use to calibrate the sphere. Navigate to the Spheres page and click Calibrate on the sphere. On a manual machine, you will be asked to manually probe the points. If the calibration fails, you will be notified. Upon successful calibration, the sphere will now have a defined center. Its calibrated status is shown by the tick next to the sphere's name. To calibrate any more spheres, you will need to make sure you have a calibrated tool selected. Once you have calibrated all your spheres, you can begin calibrating all your tools. Before calibrating a tool, you will need to set its target sphere. This is the calibrated sphere your tool will use when calibrating. Click Calibrate on a tool to start. Once completed, the tool will now have an actual probe offset. Like spheres, all orientations and tools are denoted with a tick or cross to show if they are calibrated or not. To optimize calibration, you can enable Auto Move to Sphere in Settings, which will mean the tool will automatically move to the sphere before calibrating. This needs to be enabled for you to calibrate all orientations of a tool in one run. This can be done by clicking Calibrate All on a tool. Make sure each orientation has a target sphere. You should also check the safety distance of each sphere is sufficient to prevent a crash. Finally, you can enable global parameters, which means that all tools will use the global parameters if their current move was instructed by the server user interface. They will still use their own parameters if the command came from the client. You can also set the built-in tool parameters in the settings page. Now you should know everything you need to use the Deva I++ server. Thanks for listening to this Deva tutorial. If you have any questions or problems, please consult the Deva manual for a more in-depth explanation or email Deva support@deva.co.uk.